All right, so here we go. So looking at question number 3, this is homework 9, the last one of unit 2. Inflation is 4% per year, $500 per month apartment will be how much in 10 years? So basically we want to take that $500 amount and make it go up 4% 10 times. That's basically what we're doing, right? We want to take that $500 a month price and we want it to go up 4%, right? Inflation, inflate it. That's increase the price. Increase the price 10 times. How we going to do that? How we going to? You know what we could do on that one? Well, I don't know what's the easiest way for you. Yeah, why don't we do it? We could just do, since we're doing it 10 times, we could just use that formula we used last time for interest, you know? Because that's the same thing. 1 plus r over n to the nt. Remember that interest formula? Right? There's one question using that interest formula on the exam Wednesday. No secrets with me. I just made the test. There's one. There's exactly one. Only one. Not a million, but just one. There's 25 questions, and one of them is using this thing. So make sure you have it on your 3x5. You get a 3x5 card for Wednesday's test, right? Put that thing on your card. All right, so yeah, it's just like an interest problem. It's just like saying, hey, I'm going to put $500 in the bank. It's going to grow by 4% every year for 10 years. The times are years, right? Well, it even says 10 years. I should have just said years. Right? You with me? It's just like putting money in the bank. Inflation is just like putting money in the bank and it's growing over time, except costs are growing over time. So the amount will be the principal. What's the principal? That's the 500, right? The interest rate, my little pen's not working well here. The interest rate is the 4%. So that's 0.04 is the decimal. N, what's N? N is the number of times it's compounded every year. That's just once a year here. N is 1 because, you know, whenever you do inflation, you're talking about per year. Once a year, the price goes up by 4%, right? So we're only, you know, this isn't like month. You might be thrown off by the, yeah, but it's month. Don't let that per month throw you off. That's just the rent. We're not compounding that amount or every month or something, right? We're just wondering, what's the monthly rent? We don't use that. This isn't being compounded quarterly or daily or anything. Just once a year, the price goes up by 4%. Once a year, it goes up again by 4%, right? So N is 1 time per year. And up here, N is also 1. And what is T? 10 years, huh? You with me? N is 1, T is 10. And then we just hit the buttons on our calculator. So we're going to get 500 times 1. It's going to actually be 1.04. 1.04 to the 10th. Somebody got that? Somebody quick on the draw? Nobody? Anybody? Somebody? 740.12. That looks reasonable to me. So a $500 apartment will go up to 740.12 in 10 years just because of 4% inflation. That's a little bit high. Usually inflation is around 2.5%. Typically the last decade or so. So that's a little higher than usual. That's how prices rise. You can figure out how prices are going to rise using that little formula. Make sense? Just use the A equals P 1 plus R over N to the NT form. It's like putting money in the bank. Inflation is just compounded once a year. How much it goes up per year. All right. So number 4. Basketball player makes 8 of 10 free throws. At this rate, how many attempts will he need to make 100 free throws? Can you try that one? Rather than me just whip it out. Let me give you... Anybody got a game plan that they want to share with others? No? One at a time, please. What's that? Where's that voice coming from? Okay, yeah. You guys talk without moving your mouth. It's amazing. Normally I can spot right away. Yeah. Do what with the fraction?
8 over 10.
8 over 10.
You're trying to figure out how much.
Yeah.
How many you can make 100, so 100 go on the top over x.
Good. How did you know? Like, because a lot of people would think 100 goes on the bottom. Brianna, right, Brianna? A lot of people would think the 100 goes on the bottom, but you're right. It goes on the top. How'd you know? Good job, good job. You're dialing in with the units, right? You see what Brianna, right, is doing there? So she's thinking about, like, what is the 8 and what is the 10? The 8 is, the 8 is the number made, right? The person makes 8, and the 10 is the number they attempt. So therefore, the 100 goes in the top because that's the number made, right? They made 100 free throws. So the bottom, X, is going to be the total amount they attempted. They must have attempted more than 100. Yeah, good job, good job. That's the mistake. Some people put the 100 on the bottom. All right, cross multiply. Remember how to solve two equal fractions? Diagonal, cross multiply. 8 times X is 10 times 100. What's that, 1,000 over there? And then you just divide by the 8, right? Isn't that 125? 125. There we go. Good job. We good? Questions on that? All right. I mean, they won't change because I just made them myself. They're not from the thing. They're not from the program. I just made them. Emma drove 90 miles in 2 hours. This was only 3/7 of her total trip. How far was the total trip? So I'm using my own daughter's names, Emma and Abigail. So Emma drove 90 miles in 2 hours. It's only 3/7 of the trip. How far was the total trip? So how are we going to do that? I'll give you just a second again. How about this? Can I take 3/7 of 90? Is that what I should do? What is the 3/7 of? Let's read the words really carefully. 3/7 of means times, right? In math, of is times. 3/7 of, so 3/7 times something, what? Total trip. So I should take the 3/7 and I should multiply it by total trip. Thus says the words, right? 3/7 of the total trip. So is 90 the total trip? No. The 90 is just the part that was 3/7. It's not the total trip, right? She drove 90 miles, but this was only part of her total trip. This was only 3/7 of her total trip, says the words, right? So I don't want to take 3/7 of 90, because the words say, take 3/7 of her total trip. And 90 is not the total trip, that's just the part, isn't it? So what am I going to take 3/7 of? I can just make it X, huh? Right? I think I heard Kayla say X. Right? Is that an X? Right. And that's going to equal, what's that going to equal? The 90, right? Because 3/7 of her total trip is 90 miles. Isn't that what the words are saying? Let me write that sentence, probably be more helpful if I write that. Isn't another way you could put all these words is this. 3/7 of her total trip is 90 miles. Isn't that what the words are saying in more clear words? Right? 3/7 of her total trip is the 90 miles she just drove. So 3/7 of is times total trip equals 90. Right? Just directly translate. So sometimes just putting it in a simpler sentence like that will help you then go to math. Because you got to convert, from English to math. And a simpler English sentence will make it easier to go to the math a lot of times. Okay, so now I've got that little equation. 3/7 times X is 90. Now, how do I solve for X? X is going to be total trip. That's what they're asking me for. If I could just get my hands on X, I'm done. What do you do to solve that equation for X? Do what's that? Get X by itself. And how am I going to get X by itself? I think that's a really good idea. Yeah, we got to get rid of that 3/7, huh? So one good way is just multiply by the upside down. That's exactly what I was planning to do. Just multiply by the reciprocal, the upside down, huh? But you got to do both sides, right? Whenever you deal with an equation, right? If two things are equal, you treat them the same, they'll still be equal afterwards. That's the principle, right? So I got to do the same thing on both. The 7s will cancel, the 3s will cancel. That's why that gets X alone. On the other side, just hit the buttons on your calculator, isn't it 210? So her total trip was 210 miles. 90 is a part of that. That makes sense. All is well? Questions on that one? So try to put the words into a simpler English sentence. That makes it easier to go to the math, from English to math, with a simple English sentence. All right, let's try number 6. Salary. Her salary was reduced by 1/8. If her monthly salary was $2,400, what will it be now? So her salary was reduced by 1/8. Her monthly salary was $2,400. Can you figure out what the new one is? I'll let you do that. I'm sure you can do that. Okay, so if her salary was $2,400 and she reduced it by 1/8, what does that mean you do? What'd you do, Jose?
Bring it down.
Bring it down? Yeah, so how so?
Goes down. Sorry.
Goes down what?
Goes down. So it says reduce.
Right, it's going to go down. Yeah, and how do we figure out how much? What do we do to figure out how much is it going to go down? Any ideas? What'd y'all do? Anybody?
You can use the formula like the original one, and then multiply by 1 minus.
Oh, the increase, decrease. Right. Right. Was 2,400. What will it be now? Yeah. That one where I said original times 1 plus or minus the percentage equals new. We could do that. That says origin. It means it should have said original. Anyway, that would work. So original, that's the 2,400, huh? That's what her salary was. That was the original. We could do that. And 1, is it going to be plus or minus? It's a decrease. Minus, huh? Decreases are always minus. Increases are always plus. Right? Like Jose was saying, it's a minus. It's a decrease. That's going to equal the new salary. Yeah, you could totally do that. Now, there's another easier way. You really could just divide by 8, right? And then just subtract that. And that's fine. That's what I assumed most people would do. But we can do this more formal way if you want. Here, let me finish this up and then I'll show the easier way. But both are fine. I never care how you do anything. You can just use your calculator at that point if you want. Just 2,400 times 1 minus 1/8. Or you could change 1 minus 1/8. What is 1 whole pi take away 1/8 of a pi? Somebody said, I got a whole pie, but then somebody took away 1/8 of my pie. How much of my pie is left? 7/8 of my pie. Huh. So if you multiply that, you're going to get, what, 2,100? 2,100 is her new salary. The other way is you could have, I'll just say, or just take your 2,400 and divide by 8. That'll give you your 300, and then just subtract the 300, and you get the same answer, 2,100. Right? Because if it's 1/8 reduced, then you just got to take the original salary, divide by 8. That's 1/8 of it, huh? And then just subtract that, reduce it. Either way is totally fine. Does that make sense? But part B is more tricky. Now it's good that we brought up this formula. This is going to be needed in part B because B is harder. So see if you can do B. They're switching it around. Her new salary is $2,800. What was her old salary before the reduction? That's always the harder direction. See if you can do that. A little fresh screen here. Okay, so what are we going to do? Why don't we try using the formula we just used? So I'm doing part B now. So part B, original times 1 plus or minus. Again, this is minus 1/8 because we're reducing the salary by 1/8 equals new. Now, what's the original? I don't know the original. That's what in part B. That's what they're asking me for. This is 7/8, right? 1 minus 1/8, like we did a minute ago. The new salary is the 2,800, isn't it? Right? Her new, it even says, new salary is 2,800. And I want to find her original salary before it was reduced by 1/8. So let me see, I got a whole pie, but then somebody took away 1/8 of my pie. How much of my pie is left? 7/8 of my pie. 7/8 of my pie. Is that making sense? So what do I do now to solve? This is like a big X. This original, huh? It's like my X. How do you solve for that X? What do you do to get that thing alone? Yeah, to get X by itself, what am I going to do? Yeah, we do the same thing we did before, huh? I'll just multiply by the upside down, which is, like what you're saying. So just multiply by the reciprocal, the upside down, again. Gets rid of the 8, gets rid of the 7. Then the original equals, is that 3,200? That was her salary before the reduction. It was higher. Makes sense, of course. Is that good? How are we doing? We good on those two? All right, I'll leave that on YouTube. I better get moving. I feel free. Number 7. During a road trip, Susan read a book for a fifth of the time, a magazine for a sixth of the time, talked for half the time, looked out the window for the other 20 minutes. For how long did she read? You know what? I messed up on this question. It should say, this is the ones I made, as I said, how long did she read the book? I didn't realize read wasn't a good question because she read the book and she read the magazine. That wasn't clear. I meant to say, how long did she read the book? So let's fix that right here, right now, and I'll later fix it in the homework. I was going to today, but I just ran out of time in my office. Had to get over here for class. Barely finished the practice exam. So anyway, all right, so she did a bunch of stuff. She read a book for a fifth of the time, magazine for a sixth, talked for half the time, looked out the window the other time. How long did she read the book? How in the world can we figure that out? They're not telling us the total time anywhere. Let me get a fresh screen here. So she read the book. What was it? A fifth, a sixth, a half. Read the magazine. Talked. So this is a fifth, a sixth, a half, and the other is 20 minutes. Okay. Any ideas? What should we do? This is a tricky one. Let's just start by adding those fractions. 1/5, 1/6, 1/2. Let's see what happens when we add those up. Now, how do we add those fractions? How do you add fractions? Common denominator, huh? We got to get common denominator. So what do you think the common denominator is going to be there? What is it? It's going to be 30, huh? Because 5 times 6 is 30, and 2 goes into 30. So 30. So multiply, make each of those fractions have a denominator of 30. Make each of them 30. So that means I'm going to multiply top and bottom of the first one by 6. Top and bottom of the middle one by 5. And what about the last one? 15. Top and bottom. We good to there? So that'll be 6 thirtieths plus 5 thirtieths plus 15 thirtieths. That's what? 11, 26 thirtieths. Which reduces, right? Divide top and bottom by 2. That'll be what? 13 fifteenths. Okay, so we did that. Good start. Now, just determine is that these three things for reading the book, magazine, and talking, if that all is 13 fifteenths, that's what we got, right, when we added those fractions up. If that all was 13 fifteenths of the total trip time, then the other time must be the other 2 fifteenths, right? Does that make sense? Because together they got to be everything. If somebody says, I ate 13 fifteenths of the pie, how much was left? 2 fifteenths, right? If all these things are 13 fifteenths, there must be 2 fifteenths left. So that means the other 20 minutes is 2 fifteenths of the total trip time, isn't it? So let me write what I just said. The other 20 minutes is 2/15 of the total trip time. That's true, isn't it? See, I'm trying to write a simple English sentence that will segue, lead me into a math equation, right? The other 20 minutes is 2/15 of the total trip time, right? This last 20 minutes must be 2/15 because all that other stuff is 13/15. Can I write an equation from that? Just direct translation. Can you write an equation now? So take those words, drop them straight down, and write an equation. 20 is, what's is? Equals 2/15. Well, 2/15 of, what's of? Multiply what? Total trip time. Call that X or whatever you want. It's total trip time. Call it T. How about T? T for trip. Total trip time. Okay. So can we solve for T there? What am I going to do? Same thing I did 2 other times. The reciprocal, right? Multiplied by the upside down. 2's got to go on the bottom. 15 on the top, 2 on the bottom. 15 on the top, so the 2's cancel, the 15's cancel. And we get the T, the total trip time. Now how do we work out the other side? What do you do with a fraction interacting with a whole number? You make the whole number look like a fraction, put it over 1, huh? Remember that? So it looks like a fraction there. And then cross cancel. 2 goes, you can just use your calculator. 2 goes into 20, 10 times 15, 150. So T is 150. Now, that's almost the answer to the question, but that's not quite what they asked. Did you notice what their question was? In fact, I messed up the question. It was, how long did she read the book? That's what I meant to say. So how are we going to figure out how long she read the book? What are we going to do? Yeah, because she read the book for 1/5 of the total time. So 1/5 of the 150, huh? 1/5 times of his times. 1/5 times the 150. Which is 30 minutes. She read the book for 30 minutes. That's a pretty tricky problem. There's one just like it on our exam. Maybe a little easier, not quite so many fractions, but basically very similar. Oh, no, that's right. No, 3 fractions, yeah. On our exam Wednesday. So practice this one. This one's on the practice exam. You'll see when we look at it. All right, questions on that one? Mrs. Martin bought 20. Let me write down the key facts here. 20 1/4 yards of material for 4 dresses, bridesmaid dresses. Bridesmaid dresses. And 1 flower girl dress. Which is half the size. Half the material. That's what they say. It needs only half the material of the other. So the flowers girl dress needs only half the material of a bridesmaid's dress. All right, so she bought 20 1/4 yards. She's going to use it to make 4 bridesmaid dresses and 1 flower girl dress, which uses half the material of a bridesmaid dress. So, question they're asking us, how many, each bridesmaid dress needs how many yards, and each flower girl's dress needs how many yards. She's going to use that whole 20 1/4 yards. What are we going to do? Let me let you think about it. Try to do. No thoughts? No ideas? Not even anything to try? Let's try something. Even if it's wrong, it'll get us moving. No? No takers? How many total bridesmaid dresses are being made? 4. But then that flower girl dress is how much of another bridesmaid dress? Half. So there's a sense in which she's actually making 4.5 bridesmaid dresses, right? You with me? Because the flower girl dress is half a bridesmaid dress. So couldn't we, so with that in mind, what could we do? Do what's that? Do something with the function? Kayla, is that you again? You guys could be ventriloquists. I mean, nothing moves. Make a fraction? Okay, yeah, what kind of fraction? Yeah, 20 and a fourth. Yeah, and then this is 4.5, right? It's 4.5. 4.5 bridesmaid dresses are being made. 20 and a fourth yards of material. What operation between those? She's got to take that whole 20 and a fourth yards and divide it up among 4.5 bridesmaid dresses, doesn't she? Divide, right? Does that make sense? She's got to take all the material and divide it up among 4.5 dresses. 4.5 bridesmaid dresses, right? Is that making sense? And we want to know what each one is. So that's what we really have to do. Now, how do you divide those? Well, you could just, this part will be on the calculator part where you can use your calculator. So you could just, let me show you by calc. How do you convert what's 1/4 as a decimal? 1/4? 0.25, right? You guys know a quarter is 25 cents. And what's the half? 0.5. So you could just change them both to decimals, hit the buttons on your calculator. Somebody got that? What's the answer there? What is it? 4.5. It's fun. It just comes out 4.5, huh? Just like what we're dividing by. All right, 4.5. Now, what is that 4.5? That's 4.5 yards per dress. Well, per bridesmaid dress. Bless you. So it's 4.5 yards per bridesmaid dress. That makes sense? We took all the material and divided it among 4.5 bridesmaid dresses, and we got that she's going to need 4.5 yards, 4.5 yards per bridesmaid dress. So that's the answer to the first question. Each bridesmaid dress needs 4.5 yards. Now, how much is the flower girl dress going to get? Half that. So you just divide it by 2, huh? And you're going to get 2.25, right? Half of $4.50 is $2.25. So 2.25 yards for the flower girl dress. Is that okay? Questions on that?